Alright guys, welcome to Math 0314, section 4.5, factor out the GCF. And so what we're essentially doing here is reverse distribution. So you're going to look at each of these terms and you're going to say, hey, what can I factor out? And in terms of factoring out, the greatest common factor would be we factor out the most. But don't stress over this too much. So I think when you look at this, I think most people would see that both of these are divisible by 6. All right, we can divide both by 6. We're going to do the same thing with the variables, right, with the letters. So we're going to say how many x's can we factor out? And hopefully what's apparent is that it would be x squared. And the reason why it would be x squared is you would take out the most that you can, right? And the most would be the lowest exponent, right? And since the lowest exponent is 2, that's what we're going to factor out. So, like I said, it's dividing, so we're going to put 6x squared on the outside. And the division of 12 divided by 6 is 2. X cubed divided by x squared is x. On the other side, 30 divided by 6 is 5. And x squared divide out. And so that's, let me put this in orange to make it kind of color coordinated. And that's what we would end up with. And you can check it. You could distribute back the 6x squared into both of these, and you would see you would end up getting back to the original. Okay. Now I made a comment here, which is don't stress too much over what you choose. So let's say, for example, that I look at this question, and the first thing that pops in my mind is I'm like, hey, look, they're both even, so I'm going to factor out a 2. The x squared should be obvious because you always choose the lowest exponent that they share in common, right? So you're like, okay, so I'll put a 2x squared on the outside. When I divide this, I get 6x plus 15. Well, what could you do then? Well, now you look at it again and you say, hey, can I divide any of these? Can I divide both of these by anything else? Can I factor something else out? And that's going to be 3, right? And so we would have 2x squared times 3, and then the parentheses we'd be left with 2x plus 5. And then we see that 2 times 3 is 6, which is 6x squared, 2x plus 5, which is what we originally had. And that's kind of the cool thing about this. One other perspective on this problem that you can take is that when we're looking at it, let me see, what was the original one? 12x cubed plus 30x squared. 12x cubed plus 30x squared. If we write 12 and 30 as the product of primes, 12 would be 2 times 2 times 3 x cubed, and 30 would be 2 times 3 times 5 times x squared. And you can multiply those out for yourself to see that that is actually true. And what we're doing when we factor out the GCF is I'm literally taking what they have in common. So they both have 2 2's, right? They both have 2 3's, right? And they both have, even this x cubed, if I wanted to, I could rewrite it as x times x times x, and I could do the same for the x squared. And when I look at those, I could say, well, how many do they have in common? They have 2 x's and they have 2 x's, hence x and x. That, in a nutshell, is what we're doing, right? It just becomes a lot easier just to try to figure out dividing by what they have in common here as an easier approach, right? To say, well, what's the highest I can pick? And just take a shot at what you think the highest is. And if it's not the highest, then you can look at it and be like, oh, I'll just do it again, right? Like we did here, okay? But this is why it ends up actually working out the way that it does. So hopefully that makes sense. I know it's a kind of a long explanation of that. But go ahead, take a look at number 2. Pause the video now and see if you can figure out the answer to this one. All right, going to assume that you've done so. I think the numbers is the hardest part, so when I look at 12, 30, and 3, it's got to be 3, right? If it's going to work, it's got to be 3 because 3 is prime. Then we see c squared, c cubed, and c, so you have to take the lowest, which is c, d cubed, d squared, and d, so we have to take the lowest, which is d. So we're going to factor out a 3cd. We're going to put 3cd on the outside. And what are we going to be left with? 4cd squared, right? 12 divided by 3 is 4. C squared divided by c is c. D cubed divided by d is d squared. And then we're going to continue the game. And we'll finish it off, and it looks like such. And the cool thing, other cool thing about this section is you can always check your work. You can always see that whether or not you've done it correctly, because you can always distribute it back. That's the nice part about this. Moving on to number 3, same sort of deal. One thing here is it is your choice if you want to factor out a negative or a positive. I'm just going to go ahead and just keep it positive. So 5, 10, 15, again, 5 is prime, so if it's going to work, it's got to work with 5, and it does. A to the 4th, a cubed, a squared, and then use a squared. B squared, b, you're going to have to use b. Alright. Oh, I don't know why I put a plus there. Okay, so now we're just going to put 5a squared b off to the side, and what am I going to be left with? Negative 5 divided by 5 is 1. A to the 4th divided by a squared is a squared. 2a, and then plus 3. And there we have it. So hopefully that makes sense. On to the next one. By the way, if I fail to mention it, always remember you should always be pausing the video and seeing if you can do it on your own before you watch what I'm going to do. So if you haven't done so already, go ahead and do that now. Going to assume you've done that. This is the first one that requires a little bit more thinking. Looking at this, I'm looking at the smallest number, which is 12. 12 does go into 24, but it doesn't go into 18. So the next number that pops into my mind to try is 6. So we're going to try 6 with everything, because 6 goes into 18. We have x to the 4th, x squared, and x, so we have to use the smallest, which is x. Y cubed, y, and y squared, we have to use the smallest, which is y. So we'll take that, we'll put the 6xy on the outside, and we'll be left with 4x cubed y squared minus 2x plus 3y. And again, if you're not certain, distribute it back in, double check and make sure you've done it correctly, but that is it. Moving on to the next one. This one's a little more interesting because you see parentheses and they all share x plus 2. And we can, in fact, do that. We can factor out the x plus 2. And that's going to leave me with x cubed minus x minus 9. There's nothing I can do with x cubed minus x and minus 9. They don't share anything in common. They don't all have x's. They don't all have factors of 9 other than 1. So that is it. Number 6. If you haven't done so already, pause the video. Give yourself a shot at this one. Going to assume that you've done so. And on this one, we're going to factor out a b plus 2. So we're going to put the b plus 2 on the outside. And we're going to be left with a squared plus 5. Alright? What is all this adding up to is something called factor by grouping. Factor by grouping is a very useful technique. What we do in factor by grouping is, first things first, when you see 4 terms, this is not something that is necessarily true in the real world, but in textbook land, it is very true. So anytime you see 4 terms that says factor, you're probably going to do factor by grouping, but not always. So keep that in mind. But 4 terms, right? Here's 1 term, here's 2 terms, here's 3, here's 4. Because you have 4 terms, factor by grouping is probably the move that you want to take. The first thing you always want to do is you want to look at 6, 21, 4, and 14. This is true of any sort of factoring problem. You always want to see, hey, can I factor any of those numbers out or letters out to make my life easier? Well, 6, it almost seems so because 6 and 21 is divisible by 3, but 4 is not divisible by 3, right? Then you say, okay, well, 6 is divisible by 2, and so is 4, but 21 isn't. So we have a problem here, and it's not going to work. So this is, when that is the case, usually the next move is to pair the terms. So we'll pair these two together, and let's just try to factor out what they have in common. Well, clearly 6 and 21, we said they share 3, So we're going to factor out a 3, right? And divide through by 3. They also share an a, so we'll factor out an a, so we'll factor out a 3a. And that'll leave me with 2b minus 7. And we're going to go over here, and we're going to do the same thing. Well, what does 4 and 14 share in common? They're both divisible by 2. So we're going to put 2, and this is going to be 2b minus 7. And aha! Look what happened. 2b minus 7, 2b minus 7. So we can factor now a 2b minus 7 out. And I'm left with 3a plus 2. So we took this idea that we did for 6 and 5, right? We created that situation, and then we get our solution. So hopefully that makes sense. Let's see. You guys try number 8. So pause the video now and try number 8. See if you can do that on your own. I'm going to assume you've given it a go. And first things first, don't forget this step. You're going to want to look at all the leading coefficients and see if there's something you can factor out. This case, clearly you can't because they don't all share the same letters, and they all don't have a leading. They don't share anything divisible by 7. They're not all divisible by 7. Okay, so we can't do that, but we can pair them. So we'll look at these two, and we'll pair these two, and we'll say in the first two, what can we take out? Well, it's 7 and 1, so you can't take any of the coefficients. Remember, there's a 1 here, but they do share a c in common, so we'll put a c on the outside. This will leave me with 7c plus d. Over here, these are both divisible by 2, right? So we'll take out a 2, and what does it leave me? 7c plus d. And that should be the case. These are uncommon. We can factor them out. Notice that when we factor out, you only have 2c plus d, and you're left with c plus 2. And there's my answer. Moving right along. Okay, 3x cubed plus 3x squared minus 3x minus 9. I'll go ahead and pause the video if you haven't done so already and try it on your own. I'm going to assume you've given that as a shot. Same thing, you're going to look at 1, 3, 3, and 9, and also the letters, and see if you can factor anything out. We can't, so we're just going to try factor by grouping. I'm going to pair the first two together. I'm going to say we can take out an x squared. So we'll put an x squared on the outside. That'll leave me with x plus 3. We're going to do the same thing over here. We can factor out, this time I'm going to factor out a negative 3. Now be careful here. I'm going to put a plus negative 3, and we're going to be left with x plus 3. Watch the signs on the end. This is the part that's tricky, because a negative divided by negative is a positive, and if you don't do that, these won't match up. And if those don't match up, you can't play this game. Okay. Also note that you can check your work on this, so we could, if we wanted to, we could FOIL this out, and we would get back up to here. Okay, so keep that in mind. Moving right along, number 10. Go ahead, pause the video, give yourself a shot at it. Going to assume you've done that. Going to assume also that you started off by seeing if you could factor anything out from all 4, and that's not going to be the case. This one has a 1, so that means it's going to be very hard to factor anything out, and they don't all have letters or variables. So we're going to take the first two. We can see that we can factor out an a squared out of the first two, and that'll leave me with a minus 4. The back, I can factor out a 3. I'm sorry, I said a 3, but I actually factored out a negative 3, right? And that is the trick. I mean, even I have to be careful with what I'm doing. They share an a minus 4 in common, so we'll factor that out. And we'll be left with a squared minus 3. Alright. Next one. These are bigger numbers, but same game. So go ahead, if you haven't done so already, pause the video, give it a shot, see what happens. Alright, going to assume that you've done so. When I'm looking at 24, 18, 60, and 45, I can see that they're all divisible by 3. And they all share a P. And they all share a Q. Oop. Alright? And so I'm going to factor out a 3PQ. So here's the first time that what they have in common thing I've been mentioning as the first step is actually into play. It is actually a very important first step. And the reason why it's a nice first step is it makes the problem in this situation, at least, there's less to look at, right? I'm looking at a lot less now, okay? With this inside portion now, I don't 8, 6, 20, and 15. They're not all divisible by the same thing, and they don't all have variables, so I can't factor out a variable from there. So I've done as much as I can in terms of factoring out for all four. So I'll pair them. With the first two, I can take out a 2 and a P. And with the back one, I can take out, what, a 5. So this is going to be interesting. This breaks down to 4Q minus... sorry. I'll put the 2P in front. You don't have to. You can actually put it at the back. It doesn't matter. But this will become 4Q minus 3. Over here, we're going to factor out a 5. We're going to be with 4Q minus 3. Great. That's what I wanted to see happen. I have the 3PQ on the outside. So now, I can rewrite this as, because I share a 4Q minus 3, I can put the 4Q minus 3 on the outside. And I have the 2P plus 5. And then we still have the 3PQ. And though this has, technically, this is the way we're writing it, but now that I've created a multiplication situation for everything, I don't need to write it this way. I can just drop the brackets and leave it as such. And just for good measure, I'll put the 3PQ in parentheses as well, to be clear. Okay, so that one was a little bit tougher, but more of the same, really. Go ahead, pause the video, give a shot at this one. I'm going to assume that you've done that. We're going to look here. We're going to look at the 4, the 6, the 8, and 3 and see if there's anything we can factor out. That is not the case here. We're going to look at the variables. They don't all share the same variables. So all that I have left is to try factor by grouping. And I'm going to factor out a 2 out of these first two. That's all they share in common. So we're going to get 2 on the outside, and this is going to be left with 2x plus 3PA. On the back one, there's nothing I can do there. And so I'm kind of stuck here. So there's nothing I can do here. Doesn't mean exactly that you're done with the problem. One other move you can do is you can rearrange the order of the letters. And you can try again. So just because it doesn't work doesn't mean you're done. You have to try again. So here we can factor out a 4. Here we can factor out a 3P. And we get something that almost matches up, right? It almost matches up. Because in the back, now we have x minus 2a, and this is 2a minus x. Now, there's a way we can get what's in the parentheses to match up. And the trick here, it doesn't matter which one you take, I'm going to take the first one, is we can take this and we can factor out a negative. Now, remember, when you factor out a negative, I mean a -1, what that does, essentially, is it flips the signs. Now, you might be looking at this and thinking to yourself, well, they don't exactly match up. The orders are different, right? But that's not a problem in math, right? We can just take this. 2 plus 3 is the same thing as 3 plus 2, so we can switch the order. This is called the commutative property. Just switch the order. And now we have them such that they match. So now all I have to do is factor out a 2a minus x. And I'll have the 2a minus x on the outside, and the -4 plus 3p on the other side. Now you may also see this written as 3p minus 4, and this is 2a minus x, right? And those would be equivalent, so don't stress out over that. And there may be another way to do this problem as well. So if you got the answer but you did it differently, don't discredit yourself. You probably did it right. And that's it, guys. So that's the end of the section. Hopefully that made sense. Let me know, and I'll see you in the next video.